In this video, we're going to be looking at the DFS algorithm for graph traversal. So I'm going to start at node 1 as my starting node. So that's our u value, u equals 1. And so we're going to call it DFS 1. Let's see what happens. So mark u as explored and then add u to r. So r is going to be the set that we're going to be keeping track of here. So r is set. So we're going to start by marking this as explored. I'll just put an e for explored, or ex for explored on here. And we want to add that to our set r, so 1. Now it's going to say for each edge uv incident to u, right? So what counts as that? That's these two guys. So u being the function that was the node that was put into the argument of this function. So for each edge incident to u, again, those two, if v is not marked, what's v? V is the opposite edge, end of that edge. So if v is not marked as explored, then recursively invoke DFS of v over and over and over again until you've gone through everything. So now we're going to, it's not marked as explored, so we are going to recursively, once again, call DFS of 3. Great. So now DFS of 3 is going to mark 3 as explored, right? That's the first thing that's going to happen. Mark 3 as explored. So it's going to be explored. And we're going to be adding 3 to this set here. And we, once again, ask ourselves if there are any edges leaving 3 that the opposite end has not been explored yet. So there are many, right? Any of these are options, and essentially arbitrarily pick whichever one you'd like. So the next one I'll choose as 2. So that means that we're going to be calling DFS 2. DFS. Okay. And then from here, 2 is going to be explored. We'll start with that. 2 is going to be explored. How about I make this red? We're going to be calling DFS 2. Maybe I'll put that here. DFS 2. And then 2 will be added to our list here. Now we're here. Now we're at 2. We want to now focus on 2. We want to look at all the edges incident with 2 such that the other end is not explored yet. So there's only 2 options. I'll choose the one going to 4. So we're going to be calling DFS 4. That means 4 is now explored, and 4 will be added to our set here. Once again, we want to ask, what are all the edges incident with 4 such that the opposite end is not explored? There's only one option. It has to be going to 5 now. Right, so I'm going to put 5 there. We're going to be calling DFS 5. And 5 is now going to be marked as explored. And maybe you have an array or something like that keeping track of what's explored if we were to actually implement this. Then from number 5, you have 2 options for incident edges, which the opposite end, oh sorry, not this one, only one option, where the opposite end is not explored. There's only one option, number 6. And so number 6 is there, added to the list. We're going to be calling DFS 6, and this is now marked as explored. And then we're going to start returning. So return, 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 return. And we just want to keep asking ourselves, are there any additional edges? As we're returning, we should ask ourselves, is there another edge that we can call DFS on, such that the opposite end has not been explored yet? So returning here, nothing. That's what this end for is. You're going to return after this, right? So returning, no other edges I can go to. Returning, no other edges I go to. Returning, no other edges I can go to. Returning, and here I have other edges that I can go to, right? So 7 and 8. So there's 2 options here, such that they have not been explored yet. So we can go to, let's say we go to 7. So I'm going to call DFS 7. So 7 is going to be added, 7 is going to be explored, and then 7 is going to be added to our list. And then finally, we want, we only have one option here, right? For edges that are incident, just to here. So that's going to be 8 is going to be explored. Well, I guess, sorry, we're going to call DFS 8. 8 is going to be explored. And then we add 8 to our set here. We return, which order did I do? Return, return. And we have fully returned back to the start. That is the end of our set. So we have explored, we have searched this graph, starting at our starting node 1 there, and we have traversed and found all these nodes. Now, you could get different outputs depending on the order that you choose to do the searching in, right? So, like from the beginning, I chose to go to 3 first instead of 2, and that depends on maybe how you set up the edges, or how the linked list is holding everything together, or just some arbitrary thing. Something has to just choose which one goes first, and so you'll get slightly different ordering, but you will still search in the same manner. And so the point is that you go as far into the graph as possible to begin with. So you just keep going forward as far as you can to begin with, and then return back to see if you can go any further. Okay? Whereas BFS, you search in layers. So you would start with here, and then you would also visit 2 as well. We'll talk about that another. That's all for today.